topic today is big data. I think big data stands at a pivot point not unlike 1994, in which Mark Anderson brought to the world a browser that suddenly democratized the access to the internet. But every 10 years, a technology change occurs that profoundly affects all business and often all individuals in the world. Think about semiconductors in the 70s, PCs in the 80s, the internet in the 90s. In 1994, the world opened up to the potential of books being sold online, auctions being held online. Think of Amazon and eBay. I believe we're starting that type of epoch. It's 1994 for big data. And I believe that because the implications of big data touches all aspects of everyone's lives. And that is what we're going to talk about in the big data webinar today.
So there's been a lot of talk in the last year, and it really has hit a kind of crescendo at the end of 2012 on big data. So I think it's an important topic, and people are quite interested in what does big data mean. Now, typically, what people have talked about is that big data is velocity, variety, and volume. So very, very large data sets. I think the characterization of big data can also be thought about as N equals all. What does that mean? Well, if you're a mathematician or a statistician, N equals all means you don't just sample. You get all the data, okay? All the data could be megabytes, it could be gigabytes, it could be terabytes, petabytes. But the point is, it's now all your analysis is going to use all your data. We have an abundance of data. That is one of the big pivot points of why is big data such a topic now. It's because the abundance of data, and the data isn't just about social data. It's not just about sensor data, which is being collected at a much higher pace than it ever was. It's also about historical data being digitalized. So, for example, if you wanted to know where all the wiring was under the city of New York, that has been encoded since 1888, and that has enormous number of very messy records, but that has been digitalized. And so there's a large amount of data which is being what's called datafied, or brought into a usable form. It is messy, so the theme is inexactitude. The paradigm of big data is it's no longer about precision or exactitude. Messy data is fine. Inexactitude is fine. The traditional SQL world is about exactitude. It's about precision. It's about integrity of data. The new world is about getting large data sets, N equal to all, but that data can be in a variety of forms and a variety of quality. It is all about correlations, okay? The big change of N equal to all is it's now about correlation. This process of taking historical data and turning it into useful digital data is called datafication. And you're seeing this in all industries and throughout the world, from Amazon or Google datafying all books that have ever been written, to old historical records that have been kept in an analog physical form. This is the datafication, and this is all happening in some sense because the cost of storing and processing has become so low and so economic. So today one needs to have a big data mindset. It's no longer about causality. Causality is not what is important. It's no longer about theory in the sense that we're just going to pay attention to what the data is telling us. We don't really care what the causal reasons are. We care what the correlations are. And therefore, it may be the end of experts. And Moneyball is an example. the scouts were the experts for picking the next generation of baseball players. Now there's a much greater focus on what does the data say. The experts still have some role, but the data tends to dominate more and more. An interesting example is Amazon's recommendations. They used to use human beings, individuals, but in terms of effectiveness, the algorithms beat the recommender, the people, dramatically in terms of what people bought. So N equal to all, big data, really it's all about gaining actionable insights. It's looking for signals in large data sets. The future is analytical alchemists. Okay, these are the true stars of the next decade. So there's three key players in this N equal to all world. There's the data, okay, and you need to build your lake that contains this data, and so your big data infrastructure systems experts are germane, and this is obviously where Pythian plays a critical role. There are the skills of those individuals who can take that data and manipulate that data and study that data and do correlations with that data. These big data scientists are mathematicians, economists, programmers. But the one group of people that is often missed in the discussion of big data is the what I call the Imagineers. The big data Imagineers sort of pose the, I wonder if we could figure out which routes, which flights always get delayed so that I can avoid them, or which traffic always gets stuck or busy. And so ask the big useful questions. Which premature babies are in danger of falling into illness? You need the people to ask the critical questions and then determine what data sets may help that. So, big data, N equal to all, has already been used to predict the health of premature babies. It's been used to predict delays in airlines in real time. It's being used to identify next crime locations, fire locations, failure of systems locations, failure of infrastructure. It's being used to predict what people want to buy, read, watch. A lot of the social data is obviously used for that. What do people care about? What are people interested in? It's being used to predict how people learn and better methodologies for teaching. It's being used to predict failure of manhole covers in New York City. N equal to all has been used to predict better job candidates and will continue to do so. It's being used to predict flu outbreaks. There's just a myriad of applications that have already been discovered and literally an endless number of questions that can be answered with big data. Companies such as Decide.com is an N equal to all company to help you make online purchases in the most cost effective. Prismatic, obviously choosing news feeds. Hitwise, digital marketing. Inrex, auto traffic prediction. Flightcaster, predicting flight delays. Faircast, airfare predictions. Jetpack and gaming. Fly on time, RoadNet, logistics, etc. All these companies have already been involved. So, N equal to all brings a new paradigm of pick a problem that you want to solve. You want to look for some actionable insights. You need a director of analytics. You need a new mindset. Often these are economics majors. The city of New York, put a group of young economists together, and then they started, choosing problems that would you could apply large data sets to, and you identify all the sources of data that could help you with the correlations, and you then in a very efficient way can analyze what will help you get to predicting useful insights. So obviously what is or could be datafied, you need to think about in your organization, what data do you have historically, what data are you collecting actively today, and what data could you be collecting? And then there's value in that data being the new oil. So this is a new mindset, a new paradigm shift, and you need to get the data to speak to you. So there's a lot of opportunity in all walks of business and in life. Um, so there's new capability. It requires new rules. There's understanding what problems and what data sets are available, both publicly and privately, and recognizing that there's value in that digital exhaust, that residual data that exists, and there's an enormous opportunity to exploit that data. Finally, you know, the data presents this epoch, this time, presents a wonderful opportunity to start to get ahead and gather insights before others. And a lot of it, is to do with, preventing harm, is to do with, predicting, and helping decision makers make decisions. We can never have perfect information or predictions, but they help us they're just incomplete. The more data we have, the better answers we get. And so it's a new mindset, it's a new orientation, it's a new day in which more data helps you make better decisions. Thank you for joining me in this webinar. Andrew Waitman, and I'm presenting on the topic of big data.